Again, I'm Max Valerio. I'm with Federal Highway Administration in the New Mexico Division, and I'm the area engineer for Districts 1 and 2, also aiding with Everyday Counts initiatives. The Everyday Counts is a state-based model that is shared amongst DOTs and local public agencies that identify and deploy proven yet underutilized innovations that help shorten the project delivery process, enhance roadway safety, reduce congestion, and integrate automation. All these have the benefit of saving time, money, resources for these agencies that they can use to deliver additional projects. Everyday Counts began in 2011 with Everyday Counts 1. We are now in our 10th year with Everyday Counts 6. Over this period of time, there have been over 60 innovations that have been introduced by various agencies and shared amongst the DOTs and several local public agencies and tribal organizations. New Mexico Department of Transportation has actually implemented probably more than half of these at various stages. In this afternoon, we're going to hear from 3 of these innovations, great projects that the state has taken on. The first session, the first presentation rather, will be done by Miss Priscilla Benavides. Priscilla is the Central Region Design Manager for the Department of Transportation. And Priscilla has been with the department for 20 plus years, where she has split her time in both design and construction. She's a career department employee who started in the engineer and training program in 1997. And she's held various positions in the districts and in the Office of Infrastructure. She was also granted a fellowship with AASHTO in 2008, where she worked in Washington, DC, assisting various regional committees, and she also gained experience with transportation issues at the national level. Again, she currently is the Central Region Design Manager, where she is responsible for providing the central part of the state with safe transportation services while implementing innovative, efficient, and cost-effective designs. In her personal time, she's is true to her discipline as a transportation engineer. As she says, she is her son's personal Uber driver, patrolling DOT roads while transporting her very athletic 11-year-old to many practices and games. Priscilla will feature the initiative of e-construction. Thank you very much, and we'll now listen to Priscilla's presentation.
Environment. Specific to e-construction, it is an effort to conduct business in a paperless environment by transmitting documentation electronically. E-construction is mainly accomplished by sharing the 3D model to the contractor and collaborating with the support of the technology, including that software. Today, I will be introducing our pilot project that was selected on I-40. It is key to mention that success is not only measured by cost reduction, but by updated processes and like try and implement new technologies. We took a 4-step approach in implementing EDC 4 by phase 1, define innovation processes, challenging existing processes and bringing the right people to the table. Phase 2, piloting new technology, collaborating in a different format with the use of BIM-box. Phase 3, develop construction documents, guiding your DT in the adoption of the 3D model as a model is a legal document. And finally, phase 4, implementation, bringing effort into our team for further collaboration. To further expand on phase 1, you must begin with the why. Why don't we design in 3D, dumb it down to 2D paper copy, then pay the contractor to rebuild the model that was originally designed? Not very efficient. Well, every success initiative has a champion behind it. And in this case, our champion was Robert Benson from Federal Highway. Thanks to him for assisting in the STIC grant and funded the initiative and providing the team with an opportunity for exchange with UDOT in 2019. Secondly, it is critical to have the right team with the desire to excel and think outside the box. My internal design squad, led by Greg Clark, PDE, and his two-man design squad, Orlando Miguel and Michael Brandt, exceeded all expectations and completed the project by challenging archaic processes and implementing innovation. It is also important that I mention assistance from industry by both Autodesk and Trimble. They were extremely resourceful and provided guidance through the process. The pilot project in which we selected is the 2-mile full reconstruction on Interstate 40 from mileposts 58 to 60. The control number is 6100-950. Phase 2, piloting the software. FHWA EDC program does have a STIC grant in which DOTs can apply for this grant in order to help with the implementation of the EDC. With the STIC grant that was assisted by Robert Grancy, we were able to purchase both the licenses for BIMDocs, which was the platform which we use for collaboration. All milestone reviews were hosted in BIMDocs and comments were captured electronically through BIMDocs. It was really easy to verify or cross-check review comments from milestone to milestone. Also, in addition to the STIC funding, we were also able to use iPads with cellular service that allowed both design and construction personnel to be connected with the contractor at all times. Phase 3, develop construction documents. This, in my opinion, is the bulk of the project. Several notice to contractors were created that were completely outside of the normal process. The first and probably the most important one is an NTC regarding the engineer seal. Since the 3D model was actually within the document and not necessarily the plan sets, we were unable to sign and seal every sheet within the plan set. Therefore, what we did was we added the seal to notice to contractors that indicated that this seal was representative of the 3D model. In addition to that NTC, we also had several others. The second one was for the contractor to accept and adopt the 3D model as a legal document. Upon their acceptance, they're accepting the model that they will further own. At this point, we are transferring the liability from the DOT and onto the contractor. Next, we had an NTC specific for the automated guidance machine survey equipment. We required that the contractor use Trimble Center and a Trimble base and rover equipment for automated guidance machines. The reason we chose Trimble was Trimble is the preferred software of the NM DOT, as that's what our survey section utilizes. Next would be the digital delivery coordination. The machine control guidance technology, which uses the positioning system and the robotic total stations in conjunction with the 3D computer models to determine precise location and elevations of material layers, subgrade, borrow, phase course, and hot mix. This NTC was specific for the construction inspection. They are able to verify locations, elevations, what have you, with the rover in which the contractor provides. Lastly, phase 4, implementation. We did have a mandatory period that was held in September of 2020. The project did let in October 2020, and F&F Construction was awarded the contract. They had a mandatory start date of March 1st, 2021, and they anticipate completion by 2021. They have since initiated training on the rover for the NM DOT construction personnel, and they are in the very early stages of the project. Here's a screenshot of a portion of our 3D model that was provided to FNF. Moving forward, EDC4 has allowed us to basically catapult NMDOT into EDC6, which is a digital as-built. Since we provided the 3D model for construction, we expect to receive a 3D model as an as-built in return. How we're going to implement EDC6, we're going to mirror the same processes as EDC4 with the implementation of new technology and new software. And that is later to come. We haven't worked out all the kinks and defined the actual process, but we're moving forward with that and looking forward to our successes. That is the conclusion of my presentation. Rather brief, but a quick insight to how CRV is digitizing construction. Should you have any questions, I am here to take questions. Feel free to go ahead and ask. Thank you.
Thank you, Priscilla. That was very informative. Appreciate that. And we do have some questions that have come in that we'll hold to the end of the presentation. Next, I'd like to move forward with the second presentation, which will be done by Mr. Burke Loki. Mr. Loki is the Bureau Chief and State Drainage Engineer for the department's Drainage Design Bureau. He's a civil and water resources engineer with extensive training and experience in water resources engineering and project management, acquired over 4 decades with both public and private sector organizations. As a consultant for more than 20 years, Burke led water resources groups for several major consulting firms, including Jacobs, Michael Baker, PBS&J, now Atkins. He's been responsible for the development of numerous drainage infrastructure projects for both state and local governments, as well as private developers. Burke's professional interests include sustainable drainage management practices and smarter use of state-of-art hydraulic and hydraulic models, such as 2D hydraulic modeling. His presentation actually is on hydraulic modeling, the new initiative of change. With that, I'll turn it over and start up Burke's presentation.
Every day counts 5. We participated in the UAS initiative for that, for NMDOT and our efforts and stuff. I think that the best thing for us to cover is our practices and applications based on that and what we're doing at the DOT and survey and lands engineering. With that being said, I'll get started. Accomplishments and benefits. An analysis based on strengths, opportunities, challenges was carried out by survey and lands engineering, looking at different areas of interest, utilizing UAVs for NMDOT and establishing a drone program. And when I talk about establishing a drone program, this was specifically for survey and lands engineering and how it supports and how it could support our needs for surveying and mapping. Based on literature review, survey responses, analysis, the use of UAVs for NMDOT operations improves safety, efficiency, and has reduced cost. Out of the suggested areas considered for implementing UAVs, the recommended UAV applications where NMDOT could realize benefits in safety, efficiency, and possibly cost savings are in bridge inspections. We've had some preliminary discussion with the Bridge Bureau. We haven't really done much or done anything. I mean, we've done some projects that were structures for bridges, but nothing that was directly supporting maybe bridges needs for inspection. Construction monitoring, that's another thing that we have not directly participated in out of survey and lands engineering, although it might be getting utilized, drones might be getting utilized for construction monitoring. Location field surveys. We have demonstrated practical use on field surveys. Also with road mapping, which is part of location of field surveys. Stockpile measurements, we've demonstrated practical use on them. But with that being said too, sometimes it's just easier to go out with our GPS equipment and survey a stockpile. It doesn't require as much prep up front and processing of data afterwards. So we haven't really used UAS for stockpile measurements. Drainage studies, we've utilized them for, and for aerial photography also. With the attached NM unmanned aircraft system mapping procedure checklist that was developed by Survey and Lands Engineering, NMDOT has currently performed work with UAVs in support of drainage studies, aerial photography, location surveys, and existing right-of-way conditions imposed on aerial imagery to support litigation. NMDOT has realized the benefits of safety, efficiency, and cost savings in these applications. I highlight safety because I really think that that's the biggest benefit that we've seen using drones with our field crews out, surveying out the roadway where you have some steep cut slopes, areas that are hard to navigate to on the ground, with your boots, and trying to get instruments in there to get topographic measurements. We've really benefited from the drones there. All UAVs are currently managed under Survey and Lands Engineering. They're operated by SLE staff that are certified FAA Part 107 licensees. Part 107 license requires the pilot to ensure that the drone is safe before flying by performing pre-flight visual and operational checks of the UAV to ensure that safety pertinent systems are functioning properly. UAVs will not replace many of the current activities that Survey and Lands Engineering performs, but it will complement and enhance them in regards to safety, schedule, and value. This right here on my screen now is the checklist that I had mentioned. This form gets filled out prior to and after every flight operation that we utilize the drone for. So the drones we have are assigned unit numbers. They're all registered with FAA, and they have numbers assigned to them also that's included in there. There's information as Part 107 that we include in this form. In the Part 107, there's some summary of that I'll go over on the next slide. But having flight speed, altitude information is important. Part of the pre-flight checks that take place on the equipment. Batteries, firmware updates, airspace checks, and weather conditions are all important before a crew heads out to utilize the drone. They have their pre-flight checklist that they'll go through, the crew that's out in the field operating the drone. Sometimes it's our surveyors. We have surveyors that are Part 107 certified that will use the drones. They'll fill out this checklist. We have our geospatial unit also who will request to go out and do flights in support of our surveying and mapping on projects. Especially we have a fixed wing drone, and there's a slide later on and we'll show a photo of that. But geospatial unit operates that, so they'll get scheduled out to support with the use of that drone. At the end of a flight operation, they'll go through another checklist, checking the equipment before taking it back into storage. So this is a summary of the Part 107. I know that's small and don't expect anybody to read that, but I'll highlight some of the things that are covered in it. Unmanned aircraft must weigh less than 55 pounds. That includes the payload. Daylight only operations is something we operate by. There's maximum ground speed of 100 miles per hour. That's something that's also put into that checklist that we just went over. You have a maximum altitude of 400 feet above ground that you can operate at, or 400 feet above the highest structure, but you have to remain 400 feet within that structure. Minimum weather visibility of 3 miles. Requires pre-flight inspection by remote piloting command. That's what we have our checklist for, and that's what it was developed for, to record that information. Remote piloting command certification and responsibilities. The person operating a small UAS must either hold a remote pilot airman certificate with a small UAS rating or be under the direct supervision of a person who does hold a remote pilot's certificate. Another thing they need a remote pilot needs to be able to do is they need to make available to the FAA upon request a small UAS inspection or testing and any associated documents, records required to be kept under the rules. They're responsible for conducting pre-flight inspection to include specific aircraft and control station system checks to ensure the small UAS is in condition for safety. So part of the Part 107 certifications, we have, I think, 9 to 10 NMDOT employees who are Part 107 certified. I know District 5 has their surveyors certified. District 4 has a surveyor who's certified also. But as part of going through the certification, that's where the checklist for operations was developed off of. Was them understanding what needs to be done prior to flight, during flight, and after flights. So now getting into the drones that we do have. One of the things that we had an understanding of early on was that not all UAS drones are created equal. So for us, it was having an understanding of making sure it was going to support the needs that we had in survey. And that was supporting mapping and measurements from the imagery that's being captured from the drones that we're utilizing. Not all drones are capable of supporting those needs for us. So we researched a lot on them and just made sure that they were going to meet our needs before we acquired them. This drone right here, the unique H520, was the first drone that we purchased. We purchased 4 of these drones. And one of the reasons why we purchased this is that the camera was high enough quality camera to support our needs for mapping. Plus the 6 rotary drone we felt was a lot safer than some of the 4 rotary drones. If the propeller goes out on a 4 rotary drone, bringing that drone back safely is not likely. But with the 6 propeller drone, the chances of getting it back safely are greater. And the DOT orange color probably helped a little bit too. This is the fixed wing drone. It's been about 1.5 years, 2 years that we purchased this one. This was the second, not second drone, it's a 5th drone we purchased, but the first fixed wing drone. This covers a lot more ground in a shorter period of time. The rotary drone is great for smaller areas, smaller projects, structures like bridges, you know, where you're operating in a smaller space. But the fixed wing drone is really a nice drone that can cover a lot of area in less time. The camera on this is really great. The imagery that it captures is it's amazing. The quality of the imagery that you're looking at. And with that being said, the better the quality of the imagery, the larger the files are. So when we're flying some of these projects and we have an orthomosaic, you know, of 3 miles, it's probably not practical to try and import that into Civil 3D as one image. It'll just bog it down, but we can definitely cut the imagery down to areas you know, of interest for that detail and imagery. And I'm going to go over some projects here in a little bit and just show you some of the mapping that we have done and some of the quality of the imagery that does come from the use of the drones. But before getting there, another thing that this included was not just the purchasing of the drones to assist us in our mapping. We had to also research the software and what was going to support our needs and on the production end of getting it into Civil 3D and having a Civil 3D deliverable at the end of the day. And we purchased Pix4D. That's pretty much a standard for processing imagery from UAS. It's great software. And another software we purchased is Virtual Surveyor, which is a great software at handling the imagery and processing the data and getting topographic features and surface information out of that you can then take and get into Civil 3D. All right. So here's a project that we did, New Mexico 532, Apache Creek. This is just south of Quemado, going towards Reserve on 532 is a bridge and roadway project and picking up the drainage or the river portion of that for drainage to analyze drainage there. This right here is some of the area that was mapped along the roadway. We support the mapping. This isn't just a product that comes from the processing of the data that we collect from the drone. We support it with ground surveys still. Vertically, we feel that the topographic mapping is equivalent to, you know, your standard photogrammetric mapping. Or conventional photogrammetric mapping. I never thought I'd use that word with photogrammetry, conventional, but the accuracies are the same. So we do supplement the roadway and the structures with ground survey data, and we create a surface based on, it's a hybrid surface that comes from data acquisition from the drone and ground survey. Here's some of the mapping that was produced from just the acquisition of the data with the drone, showing the contours in their topography. And then a 3D model view from Civil 3D, looking at that surface of the mapping that we're able to produce. Structure of the bridge is right here, but it's very valuable to us to be able to go out and not have to get a high flight for photogrammetry here. So cost savings are big to be able to get surveying and mapping for this project and support of design. This project right here is US 64, and there's Cimarron, another bridge structure roadway project. Mapping upstream and downstream, we know that's significant for drainage. And there's big cost savings here when we don't have to get an airplane up in the air at a high flight of 1,500 feet to fly a small project like this that we can manage with the drone and get the coverage upstream and downstream needed by drainage. And the image, the quality of the image is great. You can zoom in. If you're looking at imagery that comes from high flight and you're zooming in and they're half-foot pixels, you're not going to see the striping on the roadway like you're seeing here. There's contours that were produced from the aerial imagery that was acquired. Overall mapping surface that was prepared. Like I said, this is hybrid. Probably 85% of it is from data acquired utilizing the drone, and the 15 to 10% is ground survey, and that's mostly going to be the roadway, asphalt, and bridge, plus any other location items that we pick up on the ground and incorporated into this. There's a 3D view of that in Civil 3D. This project right here is just for imagery only, is what we requested for. There's some areas of, I'm gonna go back real quick, but areas of interest that they really wanted to look at. But we went ahead and flew the corridor of the project. I think this was 2 miles plus or minus in there. But this right here is another orthomosaic that's just really large. So we have to be able to cut that down to those areas of interest to bring into Civil 3D. Right here we have a tile of those areas of interest that they wanted to see. And I believe it was, their interest was in these cattle guard areas. So we go through there and look at these images. This is from the EB fixed wing drone. The detail in the imagery is just amazing and what you're getting here. That's the last photo of that one. I want to finish the presentation with the video. The video was prepared in 2018. So this is when we first started working with drones. I think it highlights what we were thinking back in 2018. I think it was August of 2018 is highlighting where we wanted to go with it and the direction we're going with, and the direction we're going in with it. And then being able to also participate with the EDC 5 initiative of UAS. So I want to show this. Not all the staff that are in this video are still with the DOT. Some are at the districts. Some have moved on. Some of the staff that are part of the team of working with UAS aren't in this video. Kelly Melton, he's one of the surveyors who works a lot with the data that's acquired by drone. He provided me all the imagery and processing of the data that I just went over. But we got a good team of employees, and I thought this video would highlight that some, so I'm gonna play that.
Mark, we received a comment as to whether there was sound. I don't know if you had any featured music like Burke's or any audio.
Is it not playing audio?
No, we're not hearing any audio.
Oh, wow. I don't know if I have to how I share audio. I see a thing that says start video, but I think that's from my own camera. I can turn up the audio on my speaker, but are you not hearing any audio at all, Max?
We're not hearing audio. Somebody commented that when you're sharing screen, select share audio.
Share audio. Okay. So if I go back to, if y'all just give me a second here, if I go to advanced maybe. Share computer sound. Oh, there we go. Share. Let's see if that works. And if that does, thank you for whoever made that comment to do that.
Dominguez with our surveyors
and field
crews. Conrad Roybal, field survey supervisor. Elaine Wainwright, aerial photography. Lydia Purdy with our CAD mapping group. Chris McClanahan, CAD mapping. Michael Kirchmeyer, also a photogrammetrist, and as I mentioned, Chris. These individuals behind me, majority of them are certified and licensed drone pilots. They all have their Part 107 license. They've tested for the program and taken the test down at the FHWA in Albuquerque. These are the individuals that have been assigned drones. The DOT currently has a series of 5 drones. 3 are with field crews, 4 are with field crews, 2 down in Las Cruces, with 1 assigned to the geospatial group. The purpose of the drones right now is to not only expedite the survey process, but also safety was the key factor for this. Majority of these people put themselves in harm's way every day to acquire location information for mapping for design purposes. We're still going to use them out there, but we're going to try and keep them out of the traveling public and use the drones to not only expedite the process, but also pick up additional information. The cool thing about these drones is that we can get aerial coverage that is rectified to the ground. We have both mosaics that provide us detailed information. We can also gather 3-dimensional surface data, which will then be taken over to our photogrammetry groups, and they will include the features that they will then add to mapping projects that go up to design. Right now, we do have aerial photography contracts through consultants throughout the state of New Mexico. Majority of our budget is depleted after a couple of projects. Now with the drones, we can pretty much fly every project. And with the field crews out there with the drones, they're picking up the information not only on the ground, but through the air, and we're getting a much better, clearer product for the taxpayer, for design. And as I mentioned, safety is key. So technology we're catching up with the latest technology. DOT wants to be the leaders in drone use, and we have the people here who can do that. So the survey and lands engineering has always done an amazing job to gather data. But especially now with the drone program, we're especially proud of these individuals who have taken it upon themselves to not only become certified and licensed, but to learn the rules and the applications of what drones can do. So as I mentioned earlier, DOT is headed towards the new future with the drones. Very proud of all of these individuals. Thank you.
So before I get to questions, my apologies on the video. It's quite large, so it got a little choppy there, and I hope the audio turned on. Max, I don't know if you got the audio. I was able to go in there and select share computer audio, but I hope that worked out. What was interesting is one of the things I mentioned was being able to utilize the drone to support some litigation. At the end of that video there, that area just looked like a junkyard kind of along the roadway. A lot of that was in DOT right away. And we were asked to go out and survey right away for that and do video for that. And we imposed the imagery of that onto the right away lines in CAD to show the encroachment of all that old cars and junkyard stuff that was in the right of way. With that being said, I'll wrap up my presentation, and I guess we're going to take questions, Max, at the end.
Yes, thank you, Mark. We have a couple questions and comments that came in. We'll do those at the end. Thank you very much. The video and audio worked just well. It sure is amazing to see how technology's evolved, but that was a great presentation. Thank you.
Awesome, you're welcome. And just so I'll put it out there, I give credit to the staff members and the team that make this all possible. I help facilitate these things, but by no means am I the technical guru driving the drones. I understand the applications and what they're beneficial for, and but I give credit to all the people on our staff that are supporting this. Thank you.
You bet. Thank you, Mark. Okay, we're going to go ahead and move back to Burke's presentation on change. I know he's prepared to present that live. We can go ahead and try that. Burke, if you'd like to share your screen and get that started.
Okay. I think, there you go. All right. Thank you very much, Max. And good afternoon, folks, and thank you for joining us today. We do have to be adaptable, trying to work with technology, and so I appreciate the opportunity to be here and make a presentation on change, which is the acronym for Collaborative Hydraulics, Advancing to the Next Generation of Engineering. And Lord knows people love their acronyms. So I want to start out by describing what change is about and why we're excited about it. And then we'll talk a little bit about why 2D hydraulic models are the default option, especially for bridge design, and what we at the DOT have accomplished with them to date. So what is change? Well, essentially it's one of the EDC innovation initiatives. And basically it's the application of 2D hydraulic modeling, which has become the preferred analytical approach for a lot of hydraulic kind of studies. The interface of rivers and highways always presents a lot of design challenges, and these typically favor a 2D modeling approach. Some of the concerns that are specific to highway facilities are like accurate modeling of bridge waterways and roadway overtopping, and then being able to determine the hydraulic variables needed to do good scour models. Since 2016, 2D modeling has dramatically increased for transportation agencies. There are a couple of reasons for this. One's the dang computers have gotten powerful enough to be able to do this on your desktop. Another huge factor, and kudos, shout out to Mark and his group with Survey and Lands Engineering. The only way we can do good 2D modeling is if we have good 2D or terrain data. There is significantly more high quality digital elevation data for ground terrain available now, including LiDAR. In addition to what Mark and his group is able to provide us, we're also able to get LiDAR data from USGS for a large part of the state, and they're hoping to have the entire state, I think, mapped by 2024, 2025. Another issue is the models have gotten a lot better to use, and they've got a lot better tools that help us to use that. And so I'm going to skip. 2D or numerical models have been in development, and actually HEC2 came out in the late 60s, I believe. And I guess I'm not embarrassed to say this, but I remember having a shoebox full of punch cards, running a HEC2 model, taking it down to the mainframe to have them run it. So that was when we actually started moving into numerical models. Since 2013, FHWA has started using the SRH 2D model, which is developed originally by Burek for some of their applications. And it's been heavily customized. FHWA has partnered with Burek as well as with Aquaveo to customize that particular application for transportation hydraulic design. And so because FHWA is a partner, all of the DOTs that contribute to that are also able to take advantage of this program without additional cost. When do we use 2D models? Well, FHWA's publication strongly recommends 2D models for all design scenarios that involve complex hydraulics. And those include things like wide floodplains, highly variable floodplain roughness, sinuous channels, multiple embankment openings, and moderate to high roadway skews, as well as roadway overtopping. I imagine that sounds familiar to a lot of you for IR applications in New Mexico. This is a chart out of that HDS-7 publication that pretty clearly shows how much better 2D can be for the kind of things we're doing. Some of the advantages of 2D modeling is, and this first one is a key, that 1D models require a lot of assumptions. The modeler has to go through all kinds of hoops to make sure they have a good model. And a lot of those assumptions can be somewhat subjective. For instance, trying to pick a flow path in a very wide, flat, sandy bottom floodplain can be difficult. So using the model to actually compute a lot of these parameters based on physical characteristics eliminates a lot of that subjectivity and makes the need to use a factor of safety. You don't have to be nearly as conservative is the bottom line. Again, there are very sophisticated development tools available with these models. Some of those take advantage of the kinds of the quality mapping that Mark and his group can provide, so that we can, as we're creating these models, we can use like polygons on GIS to develop the roughness factors for the stream thing. And so we can get much better, more precise results. The 2D models just inherently have a lot more variables associated with them. And there's a lot more detail that comes out of the model when we're there. And finally, the 2D models provide some really unparalleled ability to create a visualization of those results, so that you can show that both to your designers and to the stakeholders and show them precisely what's going on with a particular stream. There are disadvantages. One, the 2D model typically does require a lot more terrain data, and that has cost and schedule impacts for your project. But there are some pretty good criteria on how to define what you need for terrain data, including so your boundary conditions. They need to be far enough away from the area you're really interested in that they don't affect the results. And so sometimes we need to go half mile or more upstream and or downstream to be able to generate those appropriate boundary conditions. And the width has to be, we have to have enough width to make sure that we're containing the flow. One of the things that comes out of that is we have found that a lot of times flow, when a stream is hitting the bridge and it's starting to back up, it will spill out in places that we didn't actually expect. And so that's good to know for us. That helps us really do a better job of designing the bridge and making sure we're not creating adverse impacts. Another disadvantage is the fact that most people aren't familiar with a 2D model. And so that's an issue. Regarding that learning curve, it is steep, but it's not any more so than for RecRas 2D. And part of the issue, I think, is that as we gain more experience using 2D models, we keep finding brand new ways to use that data and apply it to get better answers. So it's kind of an evolving field. Our experience with the 2D model so far is back in 2017, one of our previous staff members, many of you probably know her, is Nicole Freet. She was able to get a STIC grant to pay for both Drainage Bureau staff and consulting engineers to attend a 3-day training class. The class was held in the general office in October 2017. It was well received, well attended. We were able to actually pay for 20 plus consultant engineers to attend the training. And we did that on purpose. We wanted to kind of jumpstart the ability of the consultant community to use these 2D models. In 2018, we actually, as an evaluation process, we completed 2D models for 5 separate bridges and a large area drainage study. We were pretty pleased with the results. So in 2019, we finished the evaluation and started moving towards institutionalizing 2D modeling as a default standard for the bridge or for the Drainage Bureau. In 2020, during the pandemic, we were able to complete models for 12 more bridges. 5 of those were by some of our on-call consultants. The other 7 were performed in-house. And we are currently working with the Bridge Bureau to complete scour evaluations using this 2D model for 18 more bridges on live streams in the state, including the San Juan and Animas, the Chama, and the Rio Grande. Our experience with 2D modeling has been that the first one takes a while. You have to get used to working on with the terrain data and the mesh, so you can get a good model. But if you can take the the National Highway Institute class, it really gets you a jump heads up. We found that after completing 2 or 3 models, our engineers are able to develop and refine models in a week or less. Obviously, acquiring the terrain data has been a challenge. Thankfully, Mark and his group and Survey and Lands Engineering have stepped up and have been able to really help us out with that. In addition, we've developed some pretty good connections with the ARGIS folks over at UNM to get their available light area data and get it, use it to make models. And so that's, between those two, we feel pretty confident that we're able to cost effectively and schedule-wise use 2D modeling to do bridge development. Some of the aspects that we are continuing to work on include figuring out ways to integrate this 2D model capability into our civil 3D design process. So what I mean by that is we want to be able to import CAD data into civil 3D or into our model, and then export the model results back out to civil 3D. We're trying to speed up and streamline that interface between our hydraulic modeling and design and the bridge design. And this is especially important and happens quite a bit where we have requirements to do grading of the channel or grading around the bridge. And so by being able to take our model, proposed model terrain data and export that out to civil 3D, we can significantly reduce the time required to do those parts of the plan development. This is an example of the kind of output we get from a 2D model. And so you'll notice that the shaded area is color coded by, and also has linear contours. That shows the water surface elevation in this case. In addition, you're seeing flow vectors that are demonstrated by arrows. So the flow vectors not only give you an indication of the velocity by the length of the arrow, but also the direction. And so we found this to be extremely helpful as we're looking at, particularly for proposed bridges, whether or not we need to skew the bridge piers if we have any. So that's an example of the kind of things, the way that the 2D model can be used to inform the design process. I wanted to point out there's a lot of available resources for 2D modeling. One of the best that we found is the FHWA has published the two-dimensional hydraulic modeling for highways in the river environment. This document is almost as long as our own drainage manual, but it's extremely useful and packed with good information. In addition, the FHWA 2D hydraulic modeling guru is Scott Hogan, works up in Denver, and he hosts a user forum roughly once every other month. But there's been a lot of great information available coming out of those forums. There's the class I talked about from the NHI. That's you can go on that website and search for class number 135095V. It means it's a virtual class. Some of the new folks in the Drainage Bureau were able to take that class just this last fall, and the rest of us took it as a refresher. It is a multi-day class. It was online, but it was extremely effective. We were all impressed with how much information we were able to get out of that class. There's also a lot of tutorials and YouTube videos available from Aquaveo to be able to learn how to use 2D modeling. Last thing I wanted to say is if you as a hydraulic engineer are not using 2D modeling, you are behind the times. You need to get up to speed with that. This is modeling using a 2D tool can be just as quick as doing a 1D model, and it can be a lot more effective. So I've thrown out a couple of questions here and provided the answers, but I know we're going to do questions here in a minute. So I'm going to end the presentation there. Thank you very much. We do appreciate you attending and joining us today. And Max, I'll turn it back over to you.
Kirk, thank you. That was an excellent presentation. Very informative too in terms of what the department's done. I would like to thank all three speakers for great presentations, very good information on what the department's doing with new innovations. And more importantly, I'd like to thank the three of them for really being the champions on these EDC initiatives. If we don't have these folks championing these initiatives, you know, they just aren't getting done. So I really like to thank them for that.